Now the amplitude, this is the resultant wave, which is also a sinusoidal wave, because we have sin kx minus omega t minus 5 prime, same like this or this. Here the amplitude was this a, here this is the amplitude, which is 2a cos del phi over 2. So the amplitude is this one. This is the amplitude of the resultant wave. Now this amplitude will define whether the interference is constructive or destructive. If I suppose that if cos delta phi over 2 is equal to 0, then the amplitude will also be equal to 0. So equation 4 implies that the resultant wave is also 0. So it means that this is a destructive interference, because the superposition of these two waves give us a wave with 0 amplitude. So it means the wave is demolishes. The waves are demolishes, or the wave cancel the effect of each other. So there is no wave. So this is a destructive interference. Now if cos del phi over 2 is equal to 1, then 5 implies the amplitude will be 2a. The amplitude will be 2a. So if the amplitude is 2a, then the resultant wave will be 2a sin kx minus omega t minus 5 prime. So it means that the amplitude is twice the amplitude of individual wave. So it means that this is a constructive interference, because the amplitude is become 2 times. It means that we have 2 waves. They are superimposed on each other such that they have the same amplitude. They have the same amplitude. They superimpose on each other. So the resultant wave has amplitude which is 2 times the amplitude of individual wave. So this is amplitude A. Both the wave have amplitude A. Here the amplitude is now 2A. So this is called constructive interference. So now we will discuss different conditions for constructive and destructive interference. And the conditions are, the first condition is, first I will discuss the constructive interference. Now we have the constructive interference. The amplitude is ym is equal to 2a cos del phi over 2. Now if I plot this cos function, I get a curve like this. Its amplitude is either +1 or its amplitude is either -1. The amplitude will be maximum. Its value will be is +1 or -1. This is cos del phi over 2. And here we have this del phi over 2. Now the value of cos del phi over 2 is either +1 or -1, maximum value. So the amplitude will be maximum. If cos del phi over 2 will be equal to +-1. Or del phi over 2 is equal to cos inverse +-1. And from cos inverse +-1 we get either 0, pi, 2 pi, 3 pi and so on. So this implies that del phi over 2 will be equals to n pi, where n is equal to 0, 1, 2, 3 and so on. Our del phi is equal to 2n pi. So the first condition for the constructive interference is if the phase difference delta phi is 2n pi, then we have constructive interference. What it means? If n is equal to 0, implies del phi will be 0. If n is equal to 1, implies del phi is 2 pi. If n is equal to 2, implies del phi is equal to 4 pi. So it means that if the phase difference is either 0 or it's 2 pi or 4 pi, if the phase difference between the phase of two waves is a 0, 2 pi, 4 pi, then we have constructive interference. Now we will calculate the path difference. Now for the path difference, we use a formula, which is delta x, the path difference divided by the wavelength, which is equal to the phase difference divided by 2 pi. So from this we can get the value of path difference, which is delta x, which is equal to delta phi over 2 pi times lambda. Now the path difference will be delta x is equal to delta phi over 2 pi times lambda. Now delta phi for constructive interference, delta phi will be 0, 2 pi, 4 pi and so on. So it means that the path difference delta x will be, if I put 0 here, we have 0. If I put 2 pi here, then 2 pi cancel with 2 pi, so we have lambda. If I put 4 pi here, then we have 2 lambda. If I put 6 pi here, then we have 3 lambda and so on. So this is the path difference. If the path difference between the two waves is either 0 or it's lambda or 2 lambda or 3 lambda, then we have a constructive interference. So what it means? Suppose we have one wave, which is this one. Now the another wave also start from the same position, such that the crest of the first falls on the crest of the second and the drift of both falls on each other. Then from this we get a constructive interference. Now next consider another case. Suppose this is a wave 1, its wavelength is this one. This is the wavelength. Now if the second wave start from this point, then the path difference will be lambda, because this wave started a lambda distance from the first one. So this wave will start from here. So again the crest and drift falls on each other. So here the path difference is lambda. So again we get a constructive interference from this one. If we have 2 lambda, then this wave will start from here. If we have 4 lambda, then it will start away from there. So this is basically the path difference. If the path difference is either 0, lambda, 2 lambda, 3 lambda, then we have constructive interference. Now we will move towards destructive interference. Destructive interference. The amplitude is again ym, which is equal to 2a cos del phi over 2. For destructive interference, this amplitude will be 0 minimum. So the minimum value of amplitude is 0. So it will be 0 only if cos del phi over 2 is equal to 0. This implies that del phi over 2 is equal to cos inverse 0. And cos inverse 0 is equal to pi divided by 2, 3 pi divided by 2, and so on. So it means it will be up to 2n plus 1 over pi over 2 into pi. So phase difference del phi will be equal to, if I bring this 2 on this side, then it will be equal to pi, 3 pi, we have 5 pi, or we have 2n plus 1 pi. Now to calculate if the phase difference is either pi, 3 pi, 5 pi, or 2n plus 1 pi, then we have destructive interference. Now to calculate the path difference by using this formula, delta x here, the path difference formula is this one. Put the value of this delta phi, which is for destructive interference here, we get path difference delta x, which is either lambda divided by 2. If I put pi here, then pi cancel with each other, so we have lambda divided by 2. If I put 3 pi, then we have 3 divided by 2 lambda. If I put 5 pi, then we have 5 divided by 2, 3 divided by 2, 5 divided by 2 lambda, and so on. If I have this 2n plus 1 pi, then we have 2n plus 1 lambda. So it means that if the path difference is either lambda divided by 2 or 3 divided by 2 lambda or 5 divided by 2 lambda or 2n plus 1 over 2, there is a 2 lambda, then we have destructive interference. So what that means? It means that suppose we have, this is a wave. The first wave is this one. The first wave is this one. So its full wave is this one. This is the full wavelength. This is lambda. So the half wavelength will be this one. This is lambda divided by 2. If the path difference is lambda divided by 2, so this wave start from this point and the second wave start from this point. So again, if we look at here, trough and crest and trough falls on each other. So this will give us destructive interference because the path difference is now lambda divided by 2. Their path difference is lambda divided by 2 because this start lambda divided by 2 first, then this one. So the path difference is here is lambda divided by 2. So the second wave start from this point. So the path difference is lambda divided by 2. If path difference is lambda divided by 2, then crest falls on trough, crest falls on trough. So this will give us destructive interference. Now let's suppose we have the path difference which is 3 lambda divided by 2. Then in this case, this is the first wave. Okay. Now this is lambda. This is lambda, and this will be lambda divided by 3 lambda divided by 2. 3 over 2 lambda, because this is lambda by 2. So lambda plus lambda by 2 is equal to 3 lambda divided by 2. Now if the path difference is 3 lambda divided by 2, then the second wave start from here. So again, if you look at here, the crest and trough falls on each other. So this will give us again the destructive interference. And similarly, if we have the path difference which is 5 pi divided by 2, 5 lambda divided by 2, 5 divided by 2 lambda, then again we have destructive interference. So this is all about interference. And the next video we will discuss about diffraction of wave. Hope you will understand this topic. Thank you.